Hi everyone, this is Professor Sebastian. We're beginning the middle third of our class where we're going to be covering chapters 4, 5, and 6 for the second exam, and we're starting off with chapter 4. Chapter 4 is sort of a standalone chapter as far as the course goes. We're going to a little bit of a side tour and take a tour of regression analysis, which is a tool that we can explore associations between variables with. So exploring associations between numerical variables, graphically and numerically. So that's what we're going to be looking at is we're talking about numerical variables. And what we're modeling is linear trends. So we're looking for something where it's trending like a line, and I'll explain that in a little bit. And the line that we're going to develop is called the regression line. In section 4.1, we're visualizing variability in the association between our two numerical variables with a scatter plot. Okay, so we'll use technology to create a scatter plot that will never be done by hand. And when we use these scatter plots, we're going to investigate the associations between the numerical variables. So visualizing variability with a scatter plot. What is a scatter plot? First of all, it's the primary tool for examining relationships between two numerical variables. Each point in a scatter plot represents one observation, usually created using technology such as a computer software program or a graphing calculator, and we're going to be using StackCrunch. Now when I say each point represents one observation, for example, look at this point right here. So in this example, we're talking about the relationship between the number of floors in a building, in other words, how many stories does that building have, as compared to the height of that building. So for example, this point right here on the x-axis, so each point has a x and a y component. The x component of that coordinate of that point is somewhere around 85. So this is a building that had 85 stories or 85 floors, and its height was somewhere around 275 feet. This is just roughly estimating. But there's several different buildings that we have that value for, how many floors they had and how tall the building was. And you can see them with all these individual dots. This is called a scatter plot. We always want to interpret a scatter plot in general by saying as x increases, in this example, as x increases, the y value tends to also increase, right? It tends to increase. It could be decreasing if it was the other way, but in this example, as x increases, y tends to increase. So for example, and we would say here, as the number of floors in buildings increases, so there's my as x increases, their height, which is y, their height tends to increase. When you're looking at a scatter plot, there's essentially three things that you're going to note. One is the trend, which means we're going to kind of imagine like if I put it right through the center of all these dots, the best line that we could put through it. All right, the trend is finding the center of the scatter plot in that way from left to right. The strength is how spread out are the points. Are they all kind of clustered tightly around the imaginary line I'm drawing through there, or kind of are they all over the place, far away from the line? So the strength would be how spread out. If it's a strong relationship between the two variables, the dots are going to be scattered close. This is actually a pretty strong relationship right here. And then the shape, whether it's linear or nonlinear. So does it even make sense to put a line through it? Okay. If it does, then it's a linear association. If it's not, then it might be nonlinear, and we'll talk more about that too.